Ladies and gentlemen, my name is Thomas Fann, and it's great that I have this opportunity to present our perspective on how auto industry can make a contribution to the future sustainable mobility. Along the change in human histories over the past centuries, Ford Motor Company has focused on innovating our production and sales for a better mobility solution. It's not only the technology innovation, but also the social innovation. Henry Ford changed the world by creating attainable mobilities for the mass. And his social innovation in many ways also helped creating a middle class. We are continuing this vision to create attainable mobility in a responsible and sustainable way. For the future, we are seeing 4 mega trends shaping the future mobilities. The first is urbanization, or growing populations in urban environments. Today, there are 28 mega cities worldwide, each with populations of more than 10 million people. And reports say that by 2030, the number will grow to more than 41. At the same time, many cities are growing. We are also seeing the second mega trend, the rapid growth of the global middle class. The global middle class will double in size by 2030 from 2 million nowadays to 4 billion, with Asia driving most of the growth. Many in this growing middle class will aspire to own a car, one of the traditional markers of economic growth. Think about the third trend, issue of air quality issues and related health risk from congestion. Of course, not all of air pollution is coming from auto, but we must admit it's one of the factors. This also urging the people to rethink what the most efficient and environmental friendly mobility could be. The fourth mega trend is the changing consumer attitude and priorities. Millennials, as we call them, most people born after the 1990s, they behave very differently from the age like me or older generations, especially when it comes to mobility. These 4 mega trends are changing the way the industry views innovation and mobility. Taking Ford as an example, this year's Ford Motor Company announced the Ford Smart Mobility Plan, which is our plan to use innovation to take Ford to next century, to next level in connectivities, mobilities, autonomous driving, consumer experience, and big data. A first critical step is the creation of a series of mobility experiments across the globe, and all designed to help us understand the way the world may move forward. We will share more detail later. Every auto brand has its roadmap to address upcoming challenges. Take Ford as an example. Our mobility roadmap guides us to conduct many experiments in near term. Try breaking through idea in technology as well as in business models. And in the midterm, we will try to focusing on the autonomous driving features and also expand the applications of all those technologies. And also develop multi-model applications. And in the long run, we intend to realize those multi-model applications system and so be a urban mobility leaders. Basically, what we are aiming to do is to make mobility affordable, as it says on the slide, economically, environmentally, socially, and provide a seamless mobility for all. And a roadmap on the connectivities. just some introduction of so-called connectivity. It's not just the infotainment system inside the car. It's beyond that. We're talking about how to make sure the car can talk to car can talk to infrastructure, and very importantly, eventually, vehicle communication to cloud. Those kind of visions we're talking about. In the near term, Ford platform is Sync. We've been working on Sync since 2006, and now has more than 12 million vehicles equipped with Sync platform, which is a great number which we can utilize a lot of new technology or develop a lot of app to utilize all those platforms. But midterm-wise, we really look at how to have embedded modules. So eventually, we have connected car, or so-called talk car. But longer term, it's part of your life. It's a connectivity. It's part of IoT, because as human beings go on living, moving always one key part of the human being life. And car will always be part of my life and be part of the connectivity. So we call it fully integrated connectivity. And then those roadmaps basically guide us to fulfill sustainability's mobility in 4 dimensions. I will introduce those 4 dimensions first and going through those slides. The first one is continuing greening our product. And second one is explore the consumer lifestyle change. And third one is to develop autonomous driving features and efficiency improvements. And the fourth one, and probably most important one, is to find out new business models. All right, let's take a look at the migration of the powertrain. Right now, people all know the green powertrain. We're talking about battery, electric vehicles, hybrid vehicles, plug-in hybrid vehicles. But don't forget, those are still costly technologies. So while we are still developing all those new technologies, most automakers also invest heavily on how to enhance efficiency of the traditional internal combustion engines and how to improve the transmission. And you have now 6-speed transmission. Very soon you will see 8, 9, 10, 11-speed transmission, all devoted to enhance this fuel efficiency. But it's a long journey, because it's not going to be an overnight change when we can suddenly drop all the internal combustion engine and move into the battery vehicles. There are a lot of technology barriers, and some conspiracies say automakers never really want to do the battery, or oil company doesn't want automakers to make electric vehicles. It's not really true, because take for example, Ford invests in the fuel cell development for more than 15 years. Every year, it's public number. You can find out. Every year, Ford spend more than billion US dollar. Well, sorry, correction, 100 million US dollar on just the fuel cell. Such a long time. It's not that easy to have a breakthrough, okay? So it's a long time migration. I'll give you an example. Like up to date, this year's, the so-called new energy vehicles, which combine the hybrid, plug-in hybrid, and battery vehicle, only accounts for less than 1.6% of the global new car sales. Only when those vehicles can reach over 10% threshold, we can consider all those are mainstream. Only when they can reach that kind of threshold, you can see a dramatic drop of the cost reduction, which then the automaker can transfer into the sales price, which then we can have an attainable new energy vehicle. So it's still a long way to go. And talking about the efficiency of the fuel roadmap, economy roadmap, those are the roadmap of Ford. Take, for example, we developed this roadmap to guide us to innovate our power efficiency together with alternative energies. We also aim to leverage those advanced and sustainable material to achieve the goal. So it's not just powertrain, the vehicle body, the material it uses. And also Ford is offering a portfolio approach. Instead of just one product, actually, I think that's not only Ford, a lot of automakers also taking similar approach, a portfolio approach, we invest in different technology and we provide different solutions to different customers in different regions. Depends on their affordabilities. So you would have the diesel engines, you have fuel cell engine in the futures, you would have LPG in some of the markets like US, in addition to all those hybrid and plug-in hybrid and battery vehicles. So this strategy we call the power of choice. It's not we choose, it's the customer choose. We just offer the portfolio. And similarly, on the material side, very important, because it's not just say we use steel, we use a lot of plastic, but for the future, if we really want to achieve a sustainable world, the material also need to be changed. And also talk about how to reuse some of the materials or how to find out a better way to manage the waste. Overall, Ford used 41 sustainable fabrics across 15 vehicle lines globally, from Mustang, Fiesta, to F-150, Taurus. We also work with other industry leaders to address the same objective of sustainability. For example, on Ford best-selling F-150, if some people visit US this year, you will know that we now changed the whole F-150 to class-exclusive aluminum alloy body, which not only strengthens the body itself, but also reduces the weight by 700 pounds. It's a huge weight reduction, which also contributes to the great fuel efficiency. So along the cycle of our product development, we always aim to build attainable and sustainable mobility solutions for our customer. It's a cycle. It's always going through this kind of customer want, environmental regulations, the future sustainability requirements, and put all those factor consideration into the product development in the very upstream, and going through the environmental friendly manufacturing process and get the product to our customer. Then continue this process to continue this sustainability cycle. And we are very honored, 2014, Ford Motor Company received the best global green brand from the Interbrand. It's also a credential to the Ford Motor Company's effort in the last several years. And talking about lifestyle change, here I would like to introduce to you a couple of experiments Ford Motor Company is conducting in different areas. This one we call My Energy Life. Is to take plug-in vehicles and work with other partners to understand how this can work together, achieve a great efficiency saving in the energy cost and also the CO2 output. For example, in this way, we actually, this is work together with the Georgia Tech, initiated in 2013, originally in US, together with Whirlpool, SunPower, Eaton, Nest. You can see that on the bottom side. And as recently as last month at CES Shanghai, also Ford Motor Company also announced similar projects, work with Delta, Haier, and Trino Sonos to develop what? A model which, with the appliance management, power management, including even sometimes solar power panel management, to see how we can create a home, achieve great energy efficiency. Cumulatively, that's the prediction of the study, it can save up to 63% of the energy cost and save 45% of the CO2 output. This is a pilot project. We are continuing doing a lot of projects. And next, another example is we call plug-in hybrid in connected world. This is a pilot project in US. Ford worked with 7 other automakers and 15 US utility companies to try to develop technology for the PHEV vehicles to talk to the utility via cloud. This open program will help manage the power and prevent the power grid overload. Just thinking very simply. if Taiwan has 1 million BEV and everybody charging during the nighttime, can our power grid sustain? Probably not. So how you manage all those charging? So you enable the technology with the between the car and the cloud of the utility company, so they can manage when to charge, when to stop. For example, at the peak time, they stop charging. But if they recognize there's a need for the driver or something need to be maintained at the vehicle, then the system can maintain the charging status. So that's kind of a connectivity work or pilot project going on in US right now. And early on, I also mentioned there are 4 dimensions that we'll work upon to fulfill the sustainability mobility. After introducing all those strategies on the product development and research on the lifestyle, let's take a look at the features help us migrate to the future autonomous driving. Actually, a lot of features right now we equip in the inside vehicle already quantify or qualify as a semi-autonomous driving. The first one is we call LiDAR. It's a light plus radar. It's a little bit like a laser technology, which enables city stop. Which, for example, when a car driving in the cities at a low speed, like a 50 or 40 kilometers per hour, suddenly a kid running in front of your car, the car can sensor the object and stop automatically, okay? All the imaging technologies using the camera to recognize the traffic sign. For example, it says 30 kilometer speed limit that can fit into the system. Either the driver slow down or the vehicle can slow down because recognizing the limit, okay? Or the lane keeping technologies using, again, the imaging to keep your car running along within the boundary of the line. Next one is radar. I think that's an easy one. This is we use in the adaptive cruise control, which very useful when you drive on the highway. You can manage your car at the safe distance with your front cars. It slow down, you slow down. It accelerated, you accelerated. It stop, you stop. Okay? You get a sense of what all those things come into. And eventually, the ultrasonic features. What I'm talking about here is all sensor technology, okay? It will help, it's self-parking, no matter it's the parking, roadside parking or perpendicular parking. So what we are doing here is actually building modular approach. If you have a total autonomous driving technology, and if you separate out each element, what Ford Motor Company is doing right now is building up each element. And also putting all those each element into the daily life usage right now. Kind of a verification or validation of each element. So once all elements complete, you have the full autonomous driving capability. That's the approach Ford Motor Company is taking right now. Take this traffic jam assistant as an example. It's a combination of a couple of the technology I just introduced, including the city stop and also the imaging technology, also the radar technology. Let's take a look.
Ford engineers are working on a traffic jam assist, which takes over a car's steering, braking, and acceleration in stop-start situations. The technology for this kind of autonomous driving is based on the further development of current driving assistance systems. New, more precise cameras will ensure the lane-keeping aid functions perfectly, even at very low speeds. In addition, the system will follow the vehicle ahead via radar and camera. Even if another vehicle suddenly cuts into the lane, the system is able to keep the vehicle in the middle of the lane, based on the existing data. The optimized ACC brakes to a full stop if required, and also starts accelerating on its own.
And the other feature, sorry. The other feature is the parking, auto parking, because also part of the future autonomous driving experience. Again, engineer at Ford try to upgrade the current auto parking capability. Eventually, we can do that. Actually, some of the pilot project been conducted, and here is some of the videos.
Engineers at Ford have developed the self-parking car. It first finds a parking space and then maneuvers into it. The driver doesn't even need to be inside. Researchers have now succeeded in installing the technology in a real car. The next step is to make it available to drivers as a feature on a production vehicle.
So combining all those technologies and connectivities technologies, we can foresee a smarter and safer transportation network. Its application can simply demonstrate in the following video.
For instance, if the lead vehicle on a road suddenly brakes, that motion would be communicated to the vehicles behind. The intersection communicates with these vehicles to assist drivers in potentially dangerous traffic situations, such as when a vehicle is about to run through a red light or a stop sign. The intersection uses technology that can monitor traffic signal status, GPS data, and digital maps, and transmit the information to surrounding vehicles.
In the meantime, Ford also worked with the University of Michigan to conduct some of the autonomous driving tests in Ann Arbor, Michigan. It's using the LiDAR system equipped on-site on the top of the vehicles. So with the innovation introduced around the vehicles, let's take a look what kind of innovation of changing business model it might be. Ford Motor Company created a serious experiment around the world and to test the breakthrough mobility idea and for better consumer experience and flexible usership, not ownership, usership models. Now let me introduce some of the models. We work with Georgia Tech on the remote repositioning technologies. It used the current LTE technology and vehicle connectivity to fulfill the remote repositioning. Such an experiment can be applied advanced parking. Let me probably explain a little bit. So for example, if you own a rental company, you don't need people to move a car from point A to point B in the future. You can drive the vehicle inside your office. For example, your customer drives a car at, say, Singapore port, and you want to drive the vehicle to the center of the Singapore city. You can do that. That's the remote positioning. Or, for example, you rush into a meeting like this one, and you drop the car at the door, and then the rental company drive your car to the nearby parking lot. That's we call remote repositioning. Okay, it's been developed and it's feasible, but of course they need a lot of tests. Okay, and another big areas of experiment is so-called car sharing. And there are different car sharing models because different market, different situation may need different models. So here, I'd like to introduce a couple. First one is in Germany. We work with our dealers and also a rental company, a car sharing company called Flinskers. So we introduced these models in 135 cities, site of the 67 cities. So that the people join this program can use the car freely, flexibly, very flexibly around the car, around the site. And in India, that's another kind of experiment. It's a smaller scale, so what we are starting in India is, for example, a group of co-workers or people living in the same apartment compound or a big family, how they can together use one vehicle, because not all people can afford to buy a vehicle, but they still want to enjoy the right to use vehicles. And then in London, this is a very interesting project we call Go Drive. It's a unique offering, one-way trip with guaranteed parking, pay as you go. You swipe your car and you take the car, just like a U-Bike in Taipei, with the pay per unit price and covering all the fee. Let's take a look how it works. Sorry. All right, it's not working anyway. That's the beauty of technology. So let me describe how that goes. Now the project expanded into phase 2, and we recruit 2,000 people to use 15 PHEV cars at 20 sites. So what they need to do, they use smartphone app to find where the car is. Once they find the car, they swipe the card, and they get into the car and kick off, and you go. And you then go to the other side, and you don't need to return the card because you park there, and next user, you can use also the app to find where the car is, and they go pick the car. For example, I'm in Taipei, and another friend is in Zhongli, for example. I drive the car there, and he wants to use that one. He registers into the system. Then he just uses the app to find out where I park the car in Zhongli, and he pick up the car and drive back to Taipei. So it's a very convenient car-sharing program, and it's expanding. I hope that we see. This is probably one of the models I think personally is quite feasible in the future, and maybe applicable to Taipei as well. So overall, we just talk about a lot of the technology and innovations here. So there are certainly a lot of opportunities. For example, all those disruptive innovations among mobile communication, vehicle connectivity. This is one big area of opportunities. The data center, because once you have all the connectivity, sensor, you generate a lot of tons of data. So how you store the data? The data management, the data center establishment is a big subject. And certainly, once you have all those data, what do you want to do with all those data? The big data analytical is the thing to go, right? Once you analyze those data, you find out something, you apply the result to develop or establish a new business model. And then in the end, of course, with all those requirements, what we need is a lot of sensors, a lot of sensors. Without those sensors, no matter it's LIDAR, radar, ultrasonic, we cannot detect. That's a very important part of the autonomous driving. And of course, very importantly, is the way to use all those data, how to develop new business models. On the other hand, there are many challenges ahead of us. The first one is the regulation and legal frame. Very simply, when two autonomous driving vehicles collide, whose fault? Is that the driver's fault, the automaker's fault, or service providers? So there are legal boundary issues, which still not very clear. And also, what kind of role government can play in all the new business model? And certainly different cycle life between the vehicle development and all those electronic features development. And then another one is, of course, infrastructure. It's not just the road. It's not just the power grid. When you generate so much data, can the current data information system sustain? Especially every car generates so many data in a second. Can you handle that? Can the system sustain? Then very importantly, once you get into the connected world, privacy and security becomes priorities. People now can hack into your computer. Can they hack into your car? If that's an autonomous driving vehicle, if some people with evil will hack into your car, hijack you, what does that mean? There are many issues in the privacy and security. And of course, always there's a tailored design versus common design issue in different markets. So how to get a scale of economy. And very importantly, no matter what kind of car, eventually we need a green power source. It's not just a battery vehicle. It's where to get the power. You can have a battery vehicle, but you have a coal burning plant, it's not working. All right, so to sum it up, like Henry Ford said in a 1920s Evening Post, he said, opening the highway to all mankind, right? So now it's about time. We are about to enter a new era of mobilities. On one hand, we have to deliver excellent products to our current customer want. On the other hand, we need intellectual horsepower, aimed to chartering a new path through these very disruptive futures. So I think every automaker like us will need your help. So let's work together for the great future. Thank you.